All right. So we've talked about how to integrate a lot of the library of functions that we have. Right? With use substitution, we can get through basically everything except logarithms and inverse trig functions. All right. So how do we do those? Well, let's start with the first one on that list. Let's look at the integral of ln x. How do we integrate this thing itself? Well, integration by parts is how we can try and do this, because we know no use substitution is going to work. So let's try out integration by parts. Now, this part here, this is like ln of x times dx. So what I'm going to do is, since the logarithm's at the top of our acronym, I'm going to make u equal to ln x, and dv is just going to be dx, something simple. Okay. Then du is 1 over x dx, and v is just x. All right. So integrating ln gives us u times v, so x ln x, minus the integral of v du. If we simplify that, that's x ln x minus the integral of 1 times dx, which is x ln x minus x plus c. That's all there is to it. So that's how we integrate the logarithm. All right, so let's look at integrating an inverse trig function. And of course, the one I'm going to pick is arctangent of x. Right? Integrating this thing is quite interesting. So what do? Well, we actually do a similar trick to ln. So u is arctangent of x. Okay. dv is going to be dx. Right? So, again, what we're doing here is we're picking u to be the first thing in that list, and dv is everything else. Now, again, what's the idea behind this is that, when we differentiate a function, it generally becomes a bit simpler. And that's going to be the case here. So, So du, this is going to be 1 over 1 plus x squared dx. Right, that's just the derivative of arctangent. Integrate this, v is x. So what do we get here? Our integral of arctangent is u times v, so x arctangent of x, minus integral of v du, which turns out to be this. All right, cool. Can we do that second integral? Turns out we can. This one's actually just a u substitution. Right, so if we do something like u is 1 plus x squared, then du is going to be 2x dx. And think back to our u substitution. This stuff right here is du. Well, 1/2 du. Right? So we get x arctangent of x minus, we're going to get 1/2 1 over u du. Right? Let's go ahead and compute that. X arctan of x minus 1/2, this is ln, absolute value of u plus c. Right? So now all we have to do is just swap everything from u back to x. So x keep forgetting the t here. Arctangent of x minus 1/2 ln 1 plus x squared plus c. And that's it. That's the integral of arctangent. So yeah, it's a bit of a complicated looking thing, but this is why we couldn't guess it right away, right? I mean, why would you guess that this should be the antiderivative of arctangent? Right? But integration by parts allows us to tackle these seemingly, impenetrable problems like this. It allows us to get in there and compute these. All right.